You open the can, that hiss, then the bite on your tongue. We call it refreshing, we call it crisp, we call it sharp. But carbonation has no flavor of its own, none at all. So why does sparkling water feel like tiny needles in your mouth? The answer is not the bubbles. The bubbles are almost a trick. What you feel is something closer to pain than to taste. Your tongue is reacting to an acid you cannot see. And the proof came from a sealed chamber and a brave volunteer. This is the story of how soda hijacks your pain nerves. Start with what is actually inside a fizzy drink. Carbon dioxide gas is forced into water under high pressure. The gas dissolves, hiding in the liquid until you crack the seal. Release the pressure, and the gas rushes back out as bubbles. For centuries, scientists assumed the bite came from these bursting bubbles. Popping bubbles, they thought, mechanically poked the surface of the tongue. It seemed obvious. More bubbles, more popping, more sharpness, right? But the obvious answer was completely wrong. The real culprit was a quiet chemical reaction on your tongue. To prove it, researchers needed to separate bubbles from chemistry. Carbon dioxide does not just sit in water, it reacts with it. CO2 plus water forms carbonic acid, a weak but real acid. This reaction is sped up by an enzyme called carbonic anhydrase. That enzyme lives right on the surface of your taste cells. As acid forms, it activates nerves that normally signal pain. The same nerves that fire when you taste something sour. In 2009, a team at the University of Southern California dug in. Her lab studied how sour taste cells detect acid. They found carbonation triggered the exact same sour-sensing cells. The gene behind it was named CAR4, a carbonic anhydrase. Block that enzyme, and the fizzy bite simply fades away. But the boldest proof came from a mountain, not a lab bench. Climbers have long reported champagne tastes flat at high altitude. Green wanted to know if pressure changed the sharpness of fizz. He placed volunteers in a hyperbaric chamber under raised pressure. Higher pressure keeps the CO2 dissolved and stops it from bubbling. If bubbles cause the bite, no bubbles should mean no sting. But the volunteers still felt the sharp burn on their tongues. No visible bubbles, yet the sting remained fully intact. The conclusion was clear: the bubbles were never the cause. The bite was chemistry, carbonic acid lighting up your nerves. Green also tested a drug used to treat altitude sickness. That drug, acetazolamide, blocks carbonic anhydrase in the body. People taking it described soda as tasting strangely flat and dull. The fizz was there, but the sharpness had quietly vanished. So here is the part that rewrites everything you assumed. What feels like taste is actually your body detecting mild pain. Carbonation activates the same nerve that responds to mustard and chili. That trigeminal nerve carries irritation, heat, and sting to your brain. It is the reason soda feels lively rather than simply wet. Your brain blends that pain signal with sweetness into pleasure. We have learned to crave a sensation built from gentle irritation. Cold makes it sharper too, by slowing the bubbles escaping. That is why warm soda tastes harsh and oddly flat. Next time you feel that crisp bite, remember the truth. You are not tasting bubbles, you are feeling a tiny, welcome burn.